Thank you very much. Ooh, this thing works. Nice. Can I get some slides? Yeah, yesterday I got pushed a little bit by Montreal guys to fill in the missing slot. And right after that, I found this post online on LinkedIn. I won't disclose the name of the person who put it there, but the nice part about this thing is that if you look really, really close over here, I'm sitting and making this presentation. So this was literally made here. All right, my name is Krzysztof, which is pretty much unpronounceable and unspellable to English speakers, so I usually go by Chris. And today I'm going to talk to you about feedback loops. If you Google feedback loop, you get a lot of different definitions, but one of my favorite ones is that it's basically any system in which the output affects the input for the next iteration. And every time you code, the innermost part, the most intimate part of coding, is this particular feedback loop, which is the code to run and to sigh, because it doesn't work. Yeah. And the important part is to start and sigh, because that's the part that you are thinking. This is the part when you write the code in your mind and then put it into computer. So it is pretty short nowadays. You can write the code and you can execute it almost instantly, but it wasn't always like that. Let's go back a little bit to the 1960s. Do you guys know what that is? Yeah, I know you guys know because I'll talk to you already about it. And Answer isn't as old to use one of those, but he probably recognized the thing. Yeah, so this is a punch card. And if you had access to one of those back then, you were really, really lucky. But most of the time, you weren't as lucky. So you write code like this. This lovely lady wrote the code for the Apollo mission program. And this is the actual code. It's printed out. She wrote it on a typewriter. And because she was lucky, she got to use a computer, but not directly. She handed out those pages to someone who typed them into the punch cards, and that person took those punch cards and gave them to a computer operator. The computer operator was a person who was basically maintaining a computer, resetting the state, because the reset wasn't a button, it was a series of switches. And after that, well, they were running the code, compiling it beforehand, of course, printing out the results because there were no screens, and mailing it using traditional email to the original programmer. So if you had this feedback loop on something like this, you give it your code to the other person rewrites it into punch card. After that, the punch card gets put in the computer, and the computer spits out the results. And 2 days later, you will receive an email that, well, not email, traditional mail, that your code fails on the second line, and you have to do it all over again. Pretty nice, huh? Yeah, so the feedback loop is a matter of days, and if you're really lucky and you're writing something important, it will be hours. But the technology gets better. So during the 1970s, we had a lot of newfangled things, and you could have one of those on your desk. You guys know what it is? It's not a computer. It's a terminal. And the nice part about this terminal, this is a VT100, is that VT100 is still being present today in this particular MacBook. It's over here. And this was the reason why the program is called terminal. It's still compatible. You could still use one of those VT100 to connect to this MacBook and use it. It's fun. But the typical usage looks something like this. And I want to point out that the important part isn't here, it's over here. This is a modem, a traditional one. It's basically a microphone that connects to a speaker in the traditional phone, and a speaker that connects to a microphone, and you have to be really quiet, because any kind of sound might disturb it and drop your connection. And you edit the code with this terminal, line by line, because you weren't able to afford to list all the program on your screen at the same time. That's way too much memory. And at some point, someone actually thought that, well, because the computers are getting cheaper and developers are getting more expensive, we should actually do something to make them more productive. And there was an editor called EX. Has anybody used EX? Has anybody used VI? Yeah, we have a couple of guys using VI. VI wasn't actually an editor back then. It was a mode for EX, and it stands for visual, so you can see the code. So we can get what you see is what you get. You can see the code on the screen, and you can edit it, and the code changes instantly. And this is amazing. Yeah. So the feedback loop on something like this is, well, typically hours, because you have to wait for other people to compile the code and run it. But if you're really lucky, on a bright day, it will be minutes. Fast forward 1980s. Well, stranger things and stuff, but also computer got cheap, at least cheap-ish. You could get a computer, and you can do this. Amazing, huh? It's local compile. You can see as the code compiles real time, and if it fails, you get the result on your screen, and you don't have to wait for other people in the queue to run your code. That's amazing. You get a feedback loop in a matter of minutes. Well, minutes, the most important part is that, well, we had minutes before, but now these are our minutes. We can have a computer. We can have two computers if we're rich, or we have a particularly good employer. Yeah, so that's the nice part. And the slowest part about this became, sorry, I clicked too soon. The slowest part about this kind of feedback isn't the computer anymore, it's a developer. Because if you run the program, you have to validate the output. You have to take a look at what it spit out and know if it works or not. So there were those guys who created a language called awk. And one of them, well, gave an interview, which is really interesting. The important part is they created this as a throwaway language, something that you don't really need to maintain anymore. But they published it, and other people started using it, as those things go. And there was one particular schmuck who wrote a CAD program in awk. Awk is a text parsing program, it's a language, so it's kind of difficult. But the guy reported the bug, which took 3 weeks of his life, and he blamed the developers, and he was really upset about this. So that's when the original developers of awk decided that, yeah, this takes time of valuable developers. We need to do something about this. And what they did in the 1980s, they wrote short programs to test the stuff that they write. Every single feature in awk got tested in the 1980s. This is way before JUnit, before TDD and stuff, but they did it anyway. And this actually made the awk the standard package of mostly any operating system. I know that the Macs recently dropped it, but it is in some kind of sort of older versions on macOS, and I think it's still in Ubuntu by default. All right, so feedback loop when you have tests is minutes, seconds. If you have a really nice test, well, maybe it's sub-second. I know Andrzej showed up his amazing, even the sourcing program, which was running tests in like, what, 10 seconds, everything? Quite a lot of that. Yeah, that's lovely. Yeah, and a lot of stuff happened between 1980s and the present day. We got much better tools. Some of them were, well, in the concept, very old, like, for example, console. But we could use this concept to show off the code and try different methods. We could do things like looking at the state of the program while it's running. We can modify it while it's running, which is pretty amazing. Even though the concept is from 1960s, the Lisp was the first one who was trying, well, the Lisp developers were the first one who tried to do something like this. But the technology wasn't there, and now it is. So we can do stuff like exploratory programming and debugging. We can explore our programs, we can stop them, we can check them, we can modify them mid-flight. We can have things like guard testing, which will run our test automatically, and we don't really have to do anything, so we can see nice pop-up results as they go. And the front-end developers have things like live reload, so they can see the changes with the same state without actually putting any input from there. So this is nice, and we have all those nice things, but not all of us. So my question for you is, when you are, you might be stuck in 60s, if you don't run your code yourself, and you think, this is crazy, we'd always run a code ourselves. Yeah, who else would be running it? Yeah. Have you ever seen a pull request in which there is a syntax error? Have you ever seen a pull request which won't work, and you know it instantly? Like, you look at it, and this doesn't make any sense whatsoever. Yeah, this is a developer stuck in the 1960s who is writing the code and letting somebody else run it for them. Like, well, there's a computer operator that will check this for me, and they will give me the result. If you don't run your code on your local machine, and by local machine, I mean something that you actually own, that you're all sole developer of, it's not shared, then you're stuck in the 1970s. This is something that I've seen quite a lot. People pushing code to continuous integration and just wait for the result. Like, they don't really run it locally because, well, what's the point? There is a continuous integration. They already have an environment. I don't need to set up on my one machine. I'm saving time, right? Yeah, but you're waiting in a queue for the people to run the code. So you're basically no better than a developer who uses terminal to, well, run the code on a shared machine. This is awful. And if you don't have tests and you have to click the stuff manually, usually on staging, because you're lazy and you don't have a local setup, you might be stuck in 80s. And even though you might mix and match, you might be on some features stuck in the 60s, some are 80s, some 70s, it's all good. Well, it would be better to be in present. So feedback loop matters. Okay, so how can we make sure that the feedback loop is as short as possible? One of the things would be, well, to throw money at the problem. This is the easiest part. Well, computers are cheap, developers are expensive. Get a better computer. Second thing would be to run stuff locally. This is very simple in the concept, very difficult in execution for some people. And the third part is to get the results quicker, which is easier said than done. Each one of those requires more work than the previous one. But if you look at the feedback loop right now, and you think about this part, people are saying it's thinking. No, you are thinking why it doesn't work. So yeah, average salary of developer. This is a random number. I didn't pull it out of any kind of statistics or anything. Let's say average senior developer earns $5,000 a month, yeah? Do we agree? Those of you who aren't, please ask for raises or something. Yeah, so let's say you run, well, work 20 days a month. You have 1 day off because you're already at 21 days. You run, let's say, 5 full test runs per day, and you can make them 10 minutes shorter by getting a new computer. Yeah, so the computer, I don't know, a newer MacBook would be like $1,500, maybe 20. So it will pay itself with 3 to 4 months. And also remember that continuous integration is also a computer. It's not a magic, it's not the cloud, it's a computer that you rent. So please track how many builds are stuck in the queue. How many PRs need a rebase that will also get redeployed to a queue in CI. And how much actually more expensive is a faster CI server? It's usually not that expensive. You can run your own. Nowadays, you can have things like GitHub self-hosted runner. You plug in your own machine, you install Docker, and you're golden. You don't have to do anything else. You just set it up, and you only pay for the machine itself. The service is free. So if you can make the build 10 minutes shorter, it's $500, which will get you a really nice server. OK, we have this thing out of the way. This is the easiest solution, just spending money. Probably software houses CEOs hate me right now because I'm talking about spending money. But the second thing is to run stuff locally. And to run stuff locally is basically to allow for prototyping things. This is the most important part of running stuff on your local machine. And because I have to go every now and then to the slides because I wrote them yesterday, sorry for interruptions, the first thing they usually see fail if I see a new project is they say, oh, we have this third-party service, so we can't really run it locally. It doesn't work because we need to integrate with Stripe. We need to integrate with this accounting service. We need to integrate with something else. Yeah, no, please mock them. It doesn't really make sense for you to not be able to run the code because you're relying on third-party service. Alt0, someone mentioned Alt0 in the previous, in the questions for the previous talk. This is also something that, well, you might have a test instance, but it's much better to have something local to test against. The second thing is that you really can use Rails console. It's not something like that you only use for extra special cases. If you want to know, for example, how many users in production, go to Rails console and count users. If you need to know if something needs performance or you need to change the index for some kind of table, please add them on production. It's not a special environment. Of course, be careful what you're doing, but still, in most cases, you can test stuff on production and get the results, get the information that you need. This is in direct opposition to what I said before about running stuff locally. But if you're developing in production, well, you're developing in production. It's not that bad. It's not that difficult, especially for performance problems, because you can't replicate them on local when local is development. And the third thing is that you should push the code very often and push it to production. Don't keep it in PRs. Nobody look at PRs when they're developing their own feature, but they will look against master. So it's better to develop code that's unfinished and hide behind the feature flag. That way you can actually try it out and see the result, and you don't have to wait for other people to interact with it. Okay. Simplify your setup, but most importantly, keep it simple, because all the place projects start with a simple setup, except if they're DDD, then you have a complicated setup, but that's another thing. But if you keep your setup simple, then the new developers joining in won't have to do those weird staging dances, and they can actually test stuff locally without any kind of interruption. Dockerize dependencies. Even if you don't Dockerize the application, because it sometimes makes it more difficult to run stuff like binding price or buy bugs or stuff, still, if you have like exotic database, let's say Mongo, Elasticsearch, put it in a Docker file, maybe Docker Compose, and use those as dependencies, and also provide the configuration for those by default. If you don't have configuration by default, some people won't use those dependencies because, well, they don't really want to configure it. And also, the most important part, reduce the number of steps for configuration. If I'm joining a project and I see a README that takes me an hour to read, well, I wasted an hour, and the setup is still complex, and it's a manual, and it's something that I will fail to do because I can't follow instructions very well. So it will be nice to have bundle DB setup plus Rails-C to at least see the console, and if you're using Docker, then Docker Compose is also fine. Please just don't make me read a long README because I will fail at this. Another thing is that you should look at the list of dependencies that you use. Each one of those gems might have a configuration that will require defaults, that require maintenance. At some point, it will fail, and if somebody switches from Intel to M1 Mac, it will fail as well. So, well, take a look at from time to time if you see if anything can be removed from that list. And the next thing is that provide seeds for all the data. If I'm setting up a project and I need to create an account that I will have a different password, then I will never reset the database because I don't want to do it over and over again. Which means in the, long enough timeline, I will stop running stuff locally because resetting database will be too troublesome. And if you use Docker, also take care of the images because they're also part of your code. There is a reason why the Docker logo is a whale, because most of the things are heavy containers that it lifts. So take a look at this code as well. All right, we got the easy part out of the way. Now it's the difficult part. I don't want to see the test suite that runs longer than 15 minutes, because if it does, I will probably switch to TikTok, Facebook, or some other social media because I can't really focus that long without having anything to do, just looking at the output. So if I jump into a project that has a slow test, what I usually do first is the easiest part. So I just browse sleep. I look into the specs and identify all the places into which the tests are waiting, because this is basically wasted developers' time. Don't think of it as a wasted computer time, because, well, computers are patient, they can wait. But the developers waiting for a CI, well, they aren't that patient, and they have other things to do. You can also grab for other things. This is also a really easy part that you could do with speeding up tests. Loops in tests. If you have a loop, and you have a test generated within the loop, what will happen is that another person will see the loop, and it's very easy to add another element. So there is another test. It doesn't really do much, because it's just another element. It's the same test, but they will add it, and they will add it over and over again. They will also do this with shared context and shared examples, because it's very easy to add them, and you have nice test coverage. So people use them all the time, even if they don't make sense. If you have like 10 subclasses and they all do the same thing, you're running the same test over and over again, even though it's just, well, just inheritance. There is nothing to do here. Another thing will be file loading. I've seen so many code bases that have some kind of image upload and have some kind of image manipulation. And they have like huge 25 megabytes PNG file because they want to really, really make sure that it works in all cases, even though it's very large. And yeah, on your local computer, this works fine because you have a faster disk. But if you put it on CI, well, it's no longer CPU bound, it's IO bound. The loading of the file will take some time. Most people, when they find those problems, so the test is running slow, at some point will browse concept like this. And they will use this particular gem for some reason. Actually, it's really, really popular. It's not bad. I have to say it's actually good. What it does is try to create an isolated environment for each process, and they will run several of them at the same time. And this will also collect the result and give you one nice output of a test. And this also works really well if you run the local. There is one minor problem with it. Here is a parallel test run. This is actually from Circle, not from parallel test, but it has the same problem. I don't know if you can see that because the resolution is a little bit crappy on this display, but the tests were running for 17 minutes, even though some of the workers finish in about 6. And there are some ways around it. You can use the timings for the previous test runs to split them more evenly. But if you have like one big test that has to run for 17 minutes, yeah, that's it. You basically have 7 extra minutes or so test. In this particular case, it's 11 minutes. So 11 minutes for every test run, and this thing costs you $500 per developer per month. And I'm quite sure the CI is cheaper. There are also some paid solutions for this kind of things. This is a screen from the marketing materials for Knapsack Pro, which is actually a server client-based solution. It starts a server that distributes tests as you go. So the workers just pick them up as they go, and this makes more even build. And there is a free solution, which I really try to love, but I actually love and hate at the same time, because it works well in local, but I never managed to get it run on CI. If somebody has some idea on how to fix this thing, because it's pretty much unmaintained right now, please do so. All right, there are some gotchas. Setup takes more time. If you want to create the database for your tests, now you have to create 10 of them, which takes time. There are some ways around it, like for example, you can set it up once in Docker, then clone the image several times. This is nice, but unfortunately, it's still usually slower than setting up just one thread. Separation isn't always complete. I've seen so many of those specs being flaky or unstable because of things like shared cache or a shared file system. There are so many ways to affect the other threads. You have to be aware of them. You have to debug them. And if you have one really big test, no matter what you do, it won't get subdivided. So if something runs for 10 minutes, even though everything else is fast, even Knapsack Pro won't help you. This will be slow. Other things you can take a look at is to make a leaner setup for your tests individually. So this time we will actually diving into some code, finally, yeah? Yeah, so this is obviously a real test. It looks very real, right? Yeah. So what this thing does is it's a request test that will call some endpoint, and will check some, well, results of what the endpoint returns. And the problem with this is that if this endpoint, for example, runs for 30 seconds or so, then you'll have to wait for 1.5 minute. The obvious solution will be to do something like this. But yeah, if you put those together, what will happen if the first assertion isn't right? So the return code will be 200, but like 300, for example, or something else. The other two won't work. And there are ways around it, and seemingly nobody uses them. You can make the test aggregate the failures. In this case, the code will go on, even though the first assertion will fail, and you get the nice reports of which of those are failing. So consider combining the slow-running tests into one test and making them aggregate the issues. This is going even deeper. This is a tool made by Evil Martians. You probably know them. It's called TestProf, but it's not mentioned in the header. So apparently they have some problems with that name. This is a huge toolkit of solutions for different kind of slowness in your tests. And the ones that are most popular are usually factory cascades. And this is a case in which you have one entity that relies on the other, and that relies on the other, and that way Factorbot pretty much builds the entire world, which is, well, obviously slow. It takes at least 7 days. So this is an example from the blog, which I shamelessly stole because I don't have time to write the code myself. This is a way of running this tool that will tell you which factor is actually slow in which particular test, so you can focus on those. And they usually fail on relations because these are cascades. So the easiest way is just remove the relations, at least make the version of the factories without the relations to particular items. You can make them also optional. There is no good way to do this in Factorybot. You have to do something with callbacks. Yeah, this sucks, but it's still faster than, well, running the entire thing all the time. And if you are really, really sure that you need the entire object, the real one, you can use create default instead of create, which will try to reuse the object that was already created. And by the way, Evil Martians, I don't know if you know them, but they are stuck in the 60s, because that's the code they published, and there is a typo here. Yeah, they don't run this code. They just post it in the blog. All right. DB or not DB? This is a nice test that will create a pony, but sometimes you don't really need to create a pony, or at least you don't really need it in your database. It's much better just to build a pony, and this won't hit the database at all, but it still provides mostly the same information, unless you're using callbacks. So every time you create an object, you can also consider going through this cycle. Try build stop, try build, try create without associations, and then create. You can think about them in about this way, which means that if I'm building stubbed, I'm testing basically something else, but I need the dependency. I need a stubbed object that I won't really be using, but it's required there, so here it is. If I'm testing this, but there is no database interaction, then use build. If I really need to create something in a database because I'm querying or inserting something in database, well, just create it, but try to not create anything else. And if you're testing end-to-end or do something more complex like request testing, yeah, you sometimes have to create the thing. And these are the basics of improving your test suite. And the question is, what's next on your feedback loop shortening list? And I know it, but I really want you to tell me your own horror stories. So please raise your hand if you can't run the code locally or your test suite is taking more than 30 minutes. OK, any taker to tell why is the situation happening in your project?
We have insane number of tests, and I'm just not working all the time on this part of the project. So I decided to not spend all my time or a few days to configure everything.
Right.
So I think I program only 3 times. I have 3 times there some tasks, so I use CI in this case. And CI runs it 3 times faster than I can do this locally. So it suits me, but I understand that if I have all the time work on this part of project, I definitely will not waiting. But you ask,
have you encountered any bugs that were related to this particular process, like something that you were sure that will work, but it failed on CI?
Yeah, I had 2 times.
Okay.
So after exactly was that I left some typo. So my CI fails almost immediately, but I have a cup of coffee when I'm waiting for in queue.
Yeah. Do you have anybody else who wants to tell about their stuff? Not really. But if you stumble upon this and you don't really want to admit, because I know it might be shameful for some people, they don't really want to admit that there is something wrong with the project, especially if it's a client project and you don't really want to, well, show yourself from the bad side. Please note down the time that it takes for you to undo the damage that was done by something that you can't run locally or time wasted for waiting for CI. And then, well, just multiply the value by your salary and reach out to somebody who pays for it. It's a really good way to have some time to improve your developer experience. And with this, I would like to jump to Q&A. Oh, there has been so many.
I just wanted to make 2 quick remarks.
Sure.
Not a questions. There is this Ruby gem called Crystal Ball. This is a remark for anyone. It takes the code coverage for each test, and if you modify a file, it will come up with a list of tests to run. So if your tests take 40 minutes, then you can take the Crystal Ball and find out the tests that only run on the files you changed.
Okay, but
This is not full CI test. You can run it locally for a quick feedback. It doesn't replace running the full suite, but it helps shorten the feedback loop.
Are you using it?
I used it in one project that was really painful.
All right.
And the CI was only solution to run the tests. You couldn't run them locally. With Crystal Ball, you could. And I wanted to share the second remark.
All right.
I'm not sure how many people use still paperclip, but I maintain a project with paperclip. And you can quickly find how to stop paperclip to not convert files. I have like products users, all of them have required files for avatars, for thumbnails and stuff like that. So there's like quick stop. You can just turn off the convert and you will always have the origin file. And there's like a more advanced stop that you can turn off the files at all. And it took my test suite from 3.5 minutes to under 30 seconds.
That's amazing. Also, thank you very much for your contributions to open source. I really enjoy using all of the gems. I know that they mentioned that you should use fewer dependencies, but I'm still grateful for that. And yeah, I wish that more people read the docs to avoid unnecessary processing.
All right. One question from here. Could you get back to the part with the? It was in the forum part with the GitHub that we could done something about that locally instead of forcing the CA to run.
It doesn't really matter right now. Let's just focus on the important thing. Yeah, you can use GitHub Actions for free. There is actually a way to only pay for the hardware. There's something called self-hosted runner, and this means that you install Docker and a small script from GitHub, and it will act as a GitHub Actions worker. You don't pay for GitHub Actions. You only pay for the server, so you can get a really beefy one, probably cheap if you're using something like Hetzner or VH or something. You can use something in cloud and use Spot instances if you really want to. So you can make much, much more powerful CI without breaking a bank and definitely under those $500. So I think that I've only mentioned this part because it's not on any of the slides.
All right, thanks.
Okay, first of all, I'm here. I'm really glad that you decided to give this talk today, because I think that this type of content is often really missing on that type of conferences. And second of all, I decided to share my story. Recently, I've changed the company and I encountered some basic CRUD service with a test suite that runs for about 15 minutes. And I decided, why does it take it so long? And I actually used the TestProf tool, and I can assure you that this is actually pretty amazing. And it turns out that the main cause of the problem was RSpec configuration, because as you all know, RSpec provides some hooks that you can configure your test. And in configuration, you can actually configure RSpec to run some code before every example. And someone decided to, I don't know who that was, but someone decided to put an clearing Rails, all the Rails cache before every example. And clearing just that one line and some few more lines reduced the time to run all the suites from 15 minutes to just 40 seconds.
Yeah, this is exactly the type of thing I really enjoy. That you find the easiest thing you can do to make the experience better for everyone. Because, well, developers are expensive, and their focus is something that we're severely lacking, especially with notifications. Well, if if you don't try actively to improve the developer experience, then YouTube wins over. Yeah.
Yep, yeah. And to sum it up, I think that one of the main problems with speeding up test suite is convincing the business to do it, because speeding up your tests from 15 minutes to like 5 minutes, from the business perspective, is not so obvious. So,
yeah, but if you put it in this term,
Yes,
they
yes,
usually understand, and that's why I encourage you to actually count those numbers and do some even write something simple for your CI to put those numbers somewhere. How long did the build take? How long was it waiting in the queue? These are simple things that we have lots of different statistics in Grafana's, in Elastic Stack, whatever we use. We have those places to log those things, but we never really do, and they map to money really nicely, which means that these are things that you can improve measurably to your company bottom line.
yes, yes. Once again, thanks for this amazing talk.
Thanks.
Thank you. That 1, 2, 3. Oh, yeah. Thank you. That was really nice presentation. I wanted to add just one more thing about what you have told about the GitHub runners. GitHub Actions, sorry.
Could you show yourself?
Yeah,
because it's
sure.
very difficult to find. Yeah, sorry. With this slide on, it's difficult to find people.
About the GitHub Actions, you have mentioned Hetzner. So in one of my previous projects, we have used Circle CI, which cost about, I think, $50 per one runner. And moving that to one of the services which allow to like use custom hardware, it was like 50 euros for one Hetzner machine, which had 8 cores. So it was able to like run 10 runners. So that was like 10 times faster for the same price, basically.
Yeah, people often forget that you can get cheap servers and they are afraid of maintenance costs for something that is bare metal. But be aware that if you run something like this, you usually only install Docker and one custom script. If it's CI for GitLab runner, GitHub runner, whatever else, it's not much of a maintenance cost, and it's really cheap to get a beefy server this way.
It was basically, it was running for a few years, and it was basically like OS updates, pretty much, like the only thing.
Awesome.
Hi.
Hello.
Does anybody use fixtures? What about fixtures?
You mean the gem fixtures, the one that has things in YAML files or something like
Yes,
that?
the YAML files instead of factory.
To be honest, I've seen them used in a couple projects. I haven't used them that much, so I don't have experience. My intuition tells me that they might be slower in some ways in terms of you have to read the file, but it might be faster in the other because you don't have to actually build stuff which is nested, because there is no option to do proper nesting, at least from what I've seen. So sorry, I don't have an experience. Maybe somebody else has some, but we can talk after that.
Okay.
Thanks for an amazing presentation. I wanted to ask, since you spent quite some time thinking about it,
Yeah, I see.
do you think we could do a better job as a community to teach people how not to shoot themselves in the foot, right? Because when you go to FactoryBot repo, it's going to tell you, hey, you can do associations, but I don't believe there's any discussion what the consequences of this are, right? Should we, maybe improve? Maybe I should open a PR and suggest, hey, we should tell people what happens when you do that. What's your opinion?
Yeah, we should definitely do something about this. Rails started as something that gave you amazing developer experience. You could build stuff in minutes, but we somehow forgot this part at some point. And the more project grows, the less we care about the things like being able to work effectively with the code base. I've seen so many propositions to solve this issue in some way, one on the other, during this conference. So I really enjoyed that. But yeah, things that are like on the level of libraries, FactoryBot, maybe, I don't know, migrations. Migration is also a difficult topic for junior developers. We don't really have good kind of tutorials, good kind of materials that we can show the junior developers and good practices. We are severely lacking in this case, but well, somebody has to do it, and I'll be happy to see it, but unfortunately, time is limited, and I can't really do anything. Well, everything. I can do something. So yeah, I agree, but it's a problem that we have to solve as a community.
Hi, thanks for the great talk, and thanks for your courage to just go and quickly prepare a presentation for an empty slot. And I would like to adapt on that comment about the crystal ball. I haven't heard about this one, but I don't know if anyone here have ever used this tool, which is called Guard. It's not new. I've used it with success. It's like a tool that tracks which files you change, and you can interact on when a file is changed. So it can even like speed up running just the tests you need when you modify a file. Of course, it requires some setup, and maybe it doesn't run all the tests you need. Maybe you can integrate it with that crystal ball, for example. But my experience was that many times it ran the test quicker than I was able to open up a console to check what's the result, and it was already there.
Yeah,
So.
it also has a nice feature. I don't know if the current Guard has it, but I've seen some implementations that have like a notification that shows like a pop-up notification in the top right corner of the screen that would just say it's all green or not. And some of those are clickable, so you can click it and go to the failing test. Yeah, this is a really nice way to shorten a feedback loop. The only thing that I don't particularly enjoy is that you lose context if you're switching too much with this kind of thing, because the tests that are failing might be pretty much unrelated to what you're looking at. But yeah, this is a nice tool.
I would like to respond to the question regarding fixtures.
Yeah, sure.
So from my experience, fixtures are great, but hard to maintain when the project grows. But the game that you mentioned, TestProf, has a great addition to the factory bot that you can actually cache them and use as a fixture. And I use them mainly for things that are like common in a project, like current user or company or whatever, that you actually can create once for all your tests, or most of them. And for the rest of the things, I use just factory bot.
Yeah, they also have a very nice feature in which you can automatically replace every single create by build, and it will log out the tests that are failing. And those tests you have to actually roll back to create, but the other one can keep build, which is a really nice way to clear out a lot of tests at once.
Hi, thank you for your talk.
Thanks.
You mentioned very nice option how to optimize your test. It's not to use database, to build objects, and but we also like this approach in our company and like to practice it. But because it's a source company, usually you're not starting projects from the scratch. Often projects comes ready, and when you want to optimize tests, but this project uses a lot of callbacks. Do you know maybe some ways around in the same time following this idea, but not to refactor the callbacks?
Well, you can't really skip refactoring the callbacks because they happen in random places. But the easiest thing I can think of when I'm jumping into, resolving those callbacks is I will just remove them. I keep the method, but I remove the callback and see what fails. This is the easiest way to find it. And if I find what fails, I usually find in the tests or in the, running the code, the places that try to use the thing that was used by the callback. And you can trace it down to just put the callback manual as a method invocation. And this way, it's not something that happens in the background. It's explicit. It's still usually a bad code because you're basically trying to fix the model after you created it at some point. It's not like the model was created properly initially, but still, there is no silver bullet, and I think this is the easiest way I found to do this. So, sorry, no good answer.
Thank you.
Third remark, and a little bit regarding what he said.
Love this guy.
I had one project that was really painful because we had MySQL there, and we were stuck with it. We couldn't upgrade or anything because we used Sphinx as a search engine, which was tightly coupled, and the running tests was horrible. Until one day I thought, why not put the whole data directory in RAM? And when you're running MySQL in Docker, that's really easy. You just add one line to Docker Compose, and the whole test suite lowered from like 10 minutes to 1 minute or 1 minute and a half. Even if you're not using MySQL, but you're still compatible with SQLite, you can always ask SQLite to be also in RAM, and that also is pretty fast.
Yeah. These are some dark art tricks that you pick up in the trenches when you're trying to optimize stuff. I really like this stuff. I think we don't have much time for more questions because the next speaker probably wants to prepare. I'm leaving with one slide that I didn't manage to put in, but it kind of sums up what we're doing in the last 60 years with software development. So basically, we're playing ping pong between putting stuff on the server and the front end repeatedly. Thank you very much.
Thanks.